Welcome to ChainX Learn.
In today's video, we will be looking at an introduction to statistics with a focus on basic terminology. At the end of this video, there will also be a quiz as well as solutions that you can use to test your skills and discern how much you've understood. What is statistics? Statistics is the science of collecting, cleaning, and analyzing data so that you can make useful conclusions. You can collect data by means of surveys, via observation, or even using readily available data from the internet. A lot of the times, if not all of the times, once you've collected data, you're going to be required to clean data. And this can include anything from missing data to merging variables. However, at this level of your statistics education, you're most likely going to always be provided with data that has already been cleaned. So this means that you're going to be provided with data that's already been cleaned and is ready for you to perform some sort of analysis on and make a useful conclusion. As an example, let us assume that a professor wants to know, on average, how many students passed his test, where the pass mark is 50%. You would most likely ask your professor for a list containing the grades for each student. This is data collection. Now let us assume that the Excel file that your professor emailed you has gotten corrupted, and you now have duplicate records. In order for your analysis to be correct, you have to go through that file and remove the duplicate records, and this is an example of data cleaning. Now your professor has asked you for an average. This is an analysis. Now we have a useful conclusion and we can tell our professor, on average, how many students passed his test. Terminology is extremely important in statistics in order to understand what you're doing and, most importantly, in order to explain what you're doing. So first we're going to define what a dataset is. A dataset is a set of values that you obtain when you're gathering information on an issue of interest. So for example, if we were interested in first year Math Test 1 grades, this is an example of what a dataset would look like. As we can see, we have two variables, student name and grade, and we have 40 observations. I will explain more about variables later on in this video. A population is all the subjects or people or elements that possess a common characteristic that's being studied. So from our previous example, our population would be made up of all 40 first-year math students. A sample is a subgroup or a subset of that population. A lot of the times in your statistics career, you're going to be working with a sample. And the reason for this is because sometimes we don't even have access to the population. So it's either you don't have access or it is not feasible, it's not within the budget for you to work with the population. So instead, we use our sample to make inferences about our population. Our sample could be 26 of the 40 first-year math students. Now, how we obtain these 26 math students is actually really interesting, and I will explain this in other videos. But essentially what we want to do is we want to choose these students randomly. So as we don't want to introduce any of our opinions or our preferences into the study, we want it to be completely random. An example of how we could do this is we could write down the names of each of the students on pieces of paper and put it in a hat and randomly draw 26 students. Another example is we could assign each student a number and randomly generate 26 numbers using Excel. A sampling frame or a sample survey frame is the actual set of elements from which a sample is drawn. Now this is really interesting. We get a population, then we get our sampling frame, and then we get our sample. So I'm going to actually explain this using an example because that's the best way. So let us assume that we want to provide a service to a particular city. And before we do this, we first want to find out if the residents of the city would actually be interested. We decide that we are going to telephonically contact the residents of the city between 8 and 5 p.m. and we're going to essentially telephonically survey them to find out if they would be interested in our service. Now, from what I said, our population would be made up of all of those residents from that particular city. However, our sampling frame, which is where we're actually drawing our sample from, is made up of those residents who meet a specific set of requirements. And these requirements are defined by the way that we are drawing up our sample. So the sampling frame in this case would be made up of those residents who have a telephone, who are at home between 8 and 5 p.m., and who are willing to take part in a survey. So whilst our population are all of those residents, our sampling frame are only those residents who meet specific requirements because of the way we are drawing up our sample. So our actual sample is coming from our sampling frame. In this specific example, we can see that our sampling frame is going to differ from our population, and it's actually going to be underrepresenting our population. This is not good. We don't want our sampling frame to underrepresent our population. In our previous example, we had 40 first-year math students. That was our population. Now, if you have access to the entire population, you can actually do a study using the entire population. And this would be called a census. So a census is a study that uses every single element of the population. A parameter is a characteristic or a measure of description obtained from a population, whereas a statistic is a characteristic or a measure of description obtained from a sample. It is really important that you understand the difference between the two and you understand when to use it. For example, if I was calculating the average in a census, I would refer to that average as a parameter. If I was calculating the average from a sample, I would refer to that as a statistic. So that is the difference. The difference between the two terms depends on the type of study we're doing, whether we're doing a census or whether we're doing a study with a sample. I mentioned a variable earlier on. A variable is a characteristic or attribute that can assume different values. It is very important for us to understand the type of variable we're working with, especially when we want to perform tests on our variables later on. We get two types of variables, qualitative variables and quantitative variables. So qualitative variables are variables that have non-numeric values, whereas quantitative variables are variables that have numeric values. So when you're looking at a variable, if it consists of numbers, you have a quantitative variable. However, if you're looking at a variable and it has non-numeric values, so it's words or it's letters, then you have a qualitative variable. So from our example with the 40 first-year math students, the first name would be an example of a qualitative variable, whereas grade would be an example of the quantitative variable. Now we can further break up qualitative and quantitative variables into nominal, ordinal, discrete, and continuous. Qualitative variables can be either nominal or they can be ordinal. A nominal variable is a categorical variable that has two or more categories but no order or ranking. An ordinal variable is a variable that has two or more categories that can be ordered or ranked. A categorical variable is a variable that can take on a value from a set of distinct possible values. For example, if we were looking at the race of a person in South Africa and we defined our races to be either African, Indian, colored, or white, so we have 4 races. So our variable race can be one of these 4 races. So it can take on a value from a distinct set of values. So it can either be white, it can either be colored, it can either be African, or it can either be Indian. And if we look at our specific races, there is no intrinsic order or ranking to them. That is that no one race is better than the other. So we would define this to be a nominal variable. However, if we were looking at maybe the grades achieved on a test where we defined it as A, B, C, D, or E, so we have 5 possible values, so it's a categorical variable again, it's non-numeric. However, in this case, our variable can be ordered or ranked, because we know that A is better than B, and B is better than C, and so forth. So when you're looking at a qualitative variable and you want to differentiate between whether it is a nominal or an ordinal variable, you have to ask yourself one question. Is there an intrinsic ranking or natural order to the values that our variable can take on? Looking at quantitative variables, they can either be discrete or continuous. Now, a discrete variable assumes a finite or a countable number of possible values. If you wanted to know how many cars were in a parking lot on a specific day, you could observe and physically count how many cars are parking in that parking lot. This is a discrete variable. It has a finite number of possible values and it is countable. However, a continuous variable assumes an infinite number of possible values. So for example, if we were interested in the weight of a person, We know that there are so many decimals in between, there's no possible way that we could say that there is a finite number of possible values that this variable can take on. So in this case, we would define weight as a continuous variable. This brings us to the end of the lesson. I hope that I've been able to assist you in some way and clear up any concepts you didn't understand. If you're interested in testing your skills, simply pause the video and go ahead and attempt the questions provided. There are solutions at the end. Thank you for watching.